Okay, so first of all, I would like to, um, you know, welcome you all. Thanks for taking out the time. Good evening and good morning, based on where you are, today. So as you see on the screen, like this webinar is purely focusing on, the Teamcenter AI, right? Teams, how the artificial intelligence is being used in the Teamcenter, and what all those use cases are there, and how it is enhancing your experience, overall experience of using Teamcenter, right? So primarily, it is if you look at the current capabilities in the Teamcenter, so you will see that AI is embedded in the Teamcenter as very similar to how you are using ChatGPT today, right? So there are the you can say like different use cases here. For example, the first one is what you see on my screen is Copilot for BOM and document. So how it is helping you like to basically find out the informations and put your questions in the chat and get the answer for those. That's we call it as document intelligence. The second one is bomb explorations. I mean, like you can navigate to the bomb bill of material. You can put like your questions in the bomb copilot and get your bomb filtered, or find out the informations in context of the bomb. At the same time, it does support traceability, and it is all like secure. We'll deep dive in all those topics, but this kind of giving you the idea of this webinar here. So, I mean, just I will spend a couple of minutes on like who we are and what we do. So, just please allow me for doing that. So, we are Next Tech, as you see on my screen, and we are specialized in PLM. Explicitly, we are a Siemens shop. We also sell and providing the services, specialized services on product lifecycle management, application lifecycle management, Polarian, Ops Center for MOM and the low code. That's kind of a Mendix here. So from the operation point of view, our headquartered in Pune, India, and we also have office in Lyon, France, for which is being taken care of for European customer base. So some of our key services offering, as I mentioned earlier, like we do a lot of things on different products here, like the PLM, Polarian, Mendix. We do the end-to-end implementations, greenfield, brownfield, upgrade and migration, and so on. We also have pretty good capabilities on customization, integrations, custom integration, writing code for maybe third-party applications, and to integrate that with the Teamcenter. And we also do some specialized services, for example, performance tuning, cybersecurity. These are our some of these are specialized services. There are very few solution provider who deal in this kind of complex areas, and we obviously have post implementation support and managed services. So from the customer point of view, we are serving more than 100 plus customer across the globe at this point of time, and that is sizing from like 15 user to 2500 users. So if there is a Teamcenter or Polarian base, maybe having 15 users, and there is a large customers who is having like more than 2500 users. We have around 150 dedicated professional, and our team is constantly growing. So that's a kind of a brief on who we are and what we do. Now let me get into the topic here. So as I mentioned earlier, this entire webinar is focusing on Teamcenter AI. So you can see here the agenda. So we are going to talk about what is AI in general, because we are talking about like how AI is enhancing the experience in the Teamcenter. So for to level base our understanding, we will talk about first on the AI part of it, and then we get into the specific of AI in Teamcenter. We will see the key business use cases, and then we also have implementation steps laid out, and then we'll maybe if there are some queries and all, like I can talk about licensing and those kind of things, and we also have FAQs towards the end of this session. Okay, so what is AI in general? I mean, it's not new to us nowadays. It's all like we are using AI almost in every applications nowadays. Even your WhatsApp, right? There is AI. Your Google, there is AI, right? So how do we define it? I mean, at the at the high level, how do we define it? What is that this area is doing in the kind of software engineering? What exactly we are trying to achieve here? So in this case, it is we are trying to mimic the human brains. That is the key of artificial intelligence. And why? Because we want some of our tasks and some of our decision making and the problem solving and reasoning and pattern recognitions we want to offload. We want some programs to take care of all these things, right? It should be able to learn like a human being. It should be able to make the predictions. It should help us to solve the problems, do the reasoning, understand the patterns, and obviously when it is doing all these things, essentially it is influencing the real or virtual environment. So it's all like in one line, it's kind of mimicking the human brain's capabilities. That is all artificial intelligence. Now you see like some of the most common example that we day in day out we make use of. For example, chat gpt, we are all aware of it. Like if there are some queries and all, we just put that into the chat gpt and we try to get the answer from. So that is a very common example of artificial intelligence, right? Essentially it uses large language models. We'll talk about what is large language model to generate the text in response to your questions or comments that you pose it. Similarly, we have Google Translate. It uses deep learning algorithm to translate your text from one language to another language. If you get into the media kind of things, then you have like Netflix, right, where the machine learning algorithm is being used for creating the personalized recommendations. Similarly, we see that in the mobile apps, mobile also, like Siri. Siri is kind of capable of understanding our questions and providing our responses and also questioning us. It's kind of a human, kind of mimicking the human behavior, like as if like you are asking somebody a question and he is responding, and if he's not getting the your question again, it will be asking you the questions, right? So that's the kind of capabilities that we see in all these different applications, right? And Teamcenter is no exception now for that. Okay, so we'll talk about some of the basic definitions here. I won't be able to get into the very detailed of all this topic, but just to set the context here, artificial intelligence is kind of a overall umbrella where all these areas are encompassed. Like for example, machine learning, deep learning, and neural networks. So what is that machine learning we talked? Essentially, it is kind of a branch for AI that actually develops the algorithms to make predictions based on certain attributes that are provided, and that's the kind of machine learning. And deep learning is basically capable of identifying the unique attributes. For example, if you are giving some input to the system, and if your program is based on the deep learning, so it will itself able to identify those unique attributes, and that is being used in the Teamcenter deep learning. Okay, and then you have a neural networks that is essentially you can see like it is kind of system that learn to perform the tasks by considering the examples or by considering the unit inputs that you give to the system, right? Now, these terms we are going to use, so I would like to touch upon this some of these terms here. Essentially, the LLM and RAG. RAG is retrieval augmented generation, and LLM stands for large language model. So now, retrieval augmented generation, what is it? It is a technology basically that combines the data retrieval and generation to provide accurate and context-rich answer by searching and using the relevant information that you can see in this picture also. Like user is making a prompt, and that goes to the data retrieval engine that gets that is searching here in the large data sources, retrieve that information, and there is a generator, and that generates the human-like or human readable, or you can say conversational response for the human. And that's the overall mechanism of the RAG, and this is kind of extension you can see here to the LLM. And LLM are designed to kind of understand the human language, and then kind of generating basically the coherent responses to the prompts and the question that human usually ask, right? And then how this is getting trained, I mean, obviously it is based on the inputs that you're going to give, right? It's kind of you can think of like LLM is kind of a foundational AI models that is being trained on vast data that we have, and where you can see like RAG or retrieval augmented technology is kind of enhancing the LLM by connecting them to external databases like vector database, right? That you can keep obviously up to date, by pushing the data or by giving the inputs to that vector database, and then uh, that is kind of you know the input where RAG is making use of, and you can see it in that way. It is more dynamic, yeah, as compared to if you see in the LLM. Like LLM is kind of a static knowledge base, but when it is combined or when it is leveraged by leveraging the RAG, so RAG is kind of a feed, a dynamic feed to the LLM. So your responses are always up to date, right? So that's the kind of terminology and the technology being used, here, LLM and the RAG, or retrieval augmented generation. Now, what is AI in Teamcenter? So we have a solutions that the name of the solution is called as Teamcenter Copilot, right? So we can chat just like Chat GPT. Like think like Chat GPT is inside the Teamcenter. You can chat, and where the knowledge is coming from, uh, how the Teamcenter is giving you the responses. Basically, it is using your documents, right? And that documents can be in any form, like PDF and Word and text and so on and so forth. So is leveraging that knowledge which you have dumped in all those documents, and to respond to your queries, right? At the same time, you can focus on a single document and fetch a specific informations and then format it. The another focus of this Teamcenter Copilot is, product structure, the bill of material, right? The configuring the bill of material, or identifying the specific parts, identifying the parts in the vicinity of some other parts. So all those different use cases are supported by Teamcenter Copilot. So now, if you go with the definition part of it, like I would simply say that it is an AI powered assistant embedded directly in the Teamcenter, the Siemens Teamcenter. Okay, and that lets the user interact with the PLM data using natural language, like how you ask somebody a questions and how you put the queries, just like two humans are talking, right? And while doing it, it is not obviously getting onto the internet and finding out the answer for you. It is all based on the informations that you are managing in the Teamcenter, and it provides a contextual answer, and as well as gives you a traceability to find out the source of the informations. Okay, so that's the Teamcenter AI, right? So now here you see, the how it is unleashing the power of conversational AI. What is conversational AI? It's conversational AI means where you can put your queries and inputs in a natural language or conversational language, and system is capable of responding you just like a human, right? So that is what is being uh, leveraged here in Teamcenter as well. So you can interact with it much the same way as you interact with ChatGPT, as I mentioned earlier. Also, Teamcenter brings you the very similar experience where you can ask the question in natural language and it generates the response or the answer, and based on this document and the textual information that you have stored in the Teamcenter. So the responses generated from the document are always traceable, right? You can see here, like if there is a response coming from for the questions, you can just easily go and find out like from which source it has particularly it has particularly used for this response, right? Then another thing is, the system is basically what we call it as hallucination-free interaction. So what does that mean essentially? Is hallucination-free means confidently telling you some false information. You're asking the questions and system is, kind of giving you a wrong answer with the confidence. Now to avoid that, it's obviously it is bounded by the data, and also there are some mechanism in Teamcenter which curb the tendencies, speculative tendencies of AI model. Okay, so that way whatever the answer you are getting, you can rely on those answers because those are all like bounded by the data. It is not going anywhere and then trying to give you some false informations. It's all like within the scope of the Teamcenter data only. Then when it is answering the question, and if there is a source, if there is source is what in Teamcenter is all like objects, right? It can be document, it can be text, or it can be PDF or image or CAD model. It's all like objects, right? Now, if user is not having, the person who is asking that question is not having the access to that particular object, then he will not he will not get the answer because it is abiding or it is honoring the Teamcenter security. So whatever the security model you have put in place, right, through the access management, it is all being honored while responding to your queries, right? Now, that's the part, where security comes into play. Similarly, when it is pushing the data to the large language models and getting the responses, it is all on the secure links. It is not like it goes outside the, uh, you know, uh, outside the basically the boundaries and get onto the internet and get the answer for you. So it utilizes the large language model in a secure, retrieval, augmented generation architecture to deliver the responses for to all your questions. Okay. Now this is this you see is a Teamcenter knowledge basis. I mean, this is a pictorial representations of what you can see is generally we would like to get answer or we would like to find out the informations based on all these functional areas, or you can say uh, from the functional standpoint, right? The first and foremost thing is part and product specification. So we have a lot of information stored in these parts and then product specification like in PDFs and Word and text and the PMI informations on CAD files and so on. So we would like to have mechanism where we can put the query and these informations will be used as a knowledge base and give me the responses. Similarly, regulations and standards. So it's kind of it can be your industry regulations or government regulations. So all those documents generally we have in the system, and obviously we want some easy mechanism to put the questions against those and get the answer for. In on the similar line, you may have the FAQs created at the department level or at the product level, from where you would like to get the response or fetch the informations, right? Work procedures where you may have a detailed procedures described in some documents that you would like to get answer for. Material specification, manufacturing process specification. So what this is trying to tell you is that your informations can be, you can structure your informations essentially in different areas. I mean, obviously we have all these informations in place, right? When you are using Teamcenter, you are having a lot of information stored in the Teamcenter, and that is not limited to the Word, that is not limited to the PDF, but it can go up to text and CAD and GIF and images and so on. This is kind of just the classification, or you can say organizing the informations based on, based on the topics, right? Now, let's talk about the key features of it. Obviously, the first and foremost feature is natural language chat. So where you can put your queries and you get the answer. The second important thing is it's a secure RAG framework, right? So that ensures that your data is secure and it enforces the access management. It is not that, as I mentioned earlier, that it is not that you will get an answer from any source, even though you do not have an access to it, right? The third important thing is hallucination free. So your responses are always accurate, because of the boundings, in context of the data, right? And it is customizable. Say, for example, you have a lot of different types of document, but you just want to create a knowledge base only for product part and product specification. You do not want to get into the industry regulations and those kind of things. So you can customize your scope to build the knowledge base, right? And obviously it's a scalable architecture. So based on your requirement, you can scale it. And most important thing is it is continuously updated. Now I can correlate this if you are already using the Solar indexing, like where somebody is creating a new item and that is getting indexed in the database. It is on the very similar line. If you are uploading a new document or you are changing the existing document, it is all being taken care of, right? And it ensures that the knowledge base is always up to date so that you get the most accurate answer and most up to date responses from the system. It is continuously updated. Okay. Now, what are those formats you can create this knowledge base, right? So there are different supported formats. I mean, you can see here. This just in classifications is kind of uh, the textual formats where you have like your Word and Microsoft Excel, PPTs, PDF, HTML, RTF, and it's all like textual informations. So Teamcenter uses Apache Tika to extract this text informations, the formats that you see here. And there are many more. So this is not an exhaustive list. This is just an example here. Then if you are having scan documents or images and those kind of things, that information is also extracted, right? The text uh, is extracted by using the OCR, optical character recognitions programs that extract all these textual informations and make it available to the knowledge base. Then you can also have the information extracted from the CAD model. Say, for example, you have some textual information there, or you may have PMI information on your CAD model, or you may have some specific information mentioned on the drawing, and you want that to be a part of your AI model. So you can configure the system, and then it can uh, it can make use of that informations for you to get the responses for your queries. Okay, so having said that, let's get into the typical business use cases here, right? So the first use case, what we are talking about, natural search, right? So it's like how, as a human, I won't give, I do not like to give the precise input like the number or a very specific attribute, right? I want to be little conversational. So that is where a natural language search comes into play. So what is this challenge we are trying to solve? Searching for data in Teamcenter with the precise inputs. We want to really overcome that and ask the question in the natural language. How does it help us? It helps us to find out the informations and get into the insight really easy and in a faster way. Now, in this case, there are two use cases I'm going to show you here. Like the first one is show me the data owned by a particular user, and this can be more specific also. You can have like more specific in query or questions. You can say like, okay, show me the data, uh, like documents and parts and owned by some user. Whatever the questions that you have in your mind, you can put it there and you can get the answer. The second use case that I'm going to show you is like there are gears in the system, and there are different projects in the systems for which the gears are developed. I would like to find out, the gear from the Pacific project. So that these are the two use cases that we are going to see right now. Okay, so let me just show you that. So here in this case, I'm getting into the natural language search. So here you see the same search mechanism, which is now powered by AI. So where I can put my query, I can just go ahead and put the query here. So here I'm putting the query as find out the what you can say is show me the part owned by Don. So that's a query system has taken in a conversational language, and you can see that it is showing me all the data which is owned by the Don, right? So this is the power of AI. I mean, I don't need to give like owner is equal to Don or something like that. Same on the similar line. I'm just trying to find out the data owned by Ed, right? So it is showing me all the data which is owned by Ed. Now the next use case in this case is like I would like to find out the gear. I would like to find out the gear which is from the specific project. So what I'm putting as in my question here is find the gears from the P101 project. So system is able to find out that gear for me and give it to me, right? So that is how this natural language works basically. So kind of you don't need to give a very precise technical input here. Rather you ask the question in your standard natural language or conversational language, and system will find out the information for you. Now the next use case here is a chat AI chat use case where I would like to find out the documents and extract the contents. So what is the challenge we are looking at here? The challenge is how can I find out the information that is buried in the documents? That's the question, right? There is no easy way to, in Teamcenter, there was no easy way before AI chat to get into to get inside the document and based on the questions and the based on the query and find out that, right? So that's the solution here. So you can see here, I would like to find out the informations by, in the documents. I'm just saying like, what is Siemens AG? So this is the questions. I'm just giving it to this AI chat, and that system is able to go and paste the information. This is little slow in my case, just because I'm not using the sizable RAM and all those things. But yeah, so you can see here now it has given me the answer. You can see like the full paragraph it has given me when I ask this question, what is Siemens AG? You can see like it says Siemens AG is a German company and so on and so forth. At the same time, you get the sources. This is kind of a traceability. So the information where it is exactly coming from, that also you can get, right? So this is kind of finding out the content in the documents, and also tracing the source of that information. You can do both. Same is the case for scan document and the PDF, right? You can go and ask the questions, and you can find out the informations even though it is uh, it is buried in like the PDF or the scan document, right? So here in this case, I'm asking this question: what are the several contributor to trust or superset of the key element of AI assurance? So this is the lengthy questions I'm asking, just to give you a feel that it is not only the simple things, but even the complex question. This does understand and find out the information for you. So it has found the document clearly, and it has also given me the trace from where it has captured that informations as a response to my question, right? So that is how you can not only use this to on these documents, textual document like Word or PPT and the text and all, but you can also get the responses based on your PDF document, scan document, or image document. There are several different several different types of files are supported for extracting the knowledge and the informations to build this model. Okay. Now the third use case here is basically how do we find out the information stored on a CAD models, right? So here in this case, you can see in the picture here, the question is locating. I would like to find out the informations. I don't know where it is. I mean, I just put the question like what countermeasure can be taken to prevent electrostatic discharge in an encoder system. That is the simple questions I have asked, and then it is giving me the response. You can see that response here. An important thing is this information is not in the text or even not in the image or the PDF, but this information was stored on the model, right? So it can also fetch make use of the informations which is there on the CAD model, such as text or even the PMI informations, right? And that way it is really easy for you to get the informations as a response, and then also trace that model uh, as you require, right? Just let me just quickly show you. So here in this case, you can see here, uh, it's like I'm just using this and I'm asking the question that I was showing you earlier, right? So what is the countermeasure can be taken to prevent electrostatic discharge in encoder system? So when I fire this query, I get the response that this is where, and then the source also. You can see that drive reductor encoder, right? So that is the particular, assembly you can see here, and you can directly open that into NX or whatever the applications you have, right? And see that information is there in that, in this case, textual information. Now, if you get into the next use case here, the BOM Copilot, This is also a very useful functionality where you can locate the required BOM content precisely and quickly. And obviously that we don't need here now to give the precise input, or you can say like part number or a specific owner or user or something like that. It's all like natural language. You just put your questions and you get the information in context of the BOM. Now, how do you do that, right? So here you open the BOM. I mean, there are two use cases that I'm going to talk about. The one is filter BOM structure based on the user inputs. So I'm going to give the uh, inputs where I would like to filter this BOM structure. So I would like to say like, this is okay. I mean, I have a really large BOM structure, but I would like to see like the components and the assemblies which is owned by a specific user. And for that, I will be putting my query in the conversational language. And the second use case is I will be selecting a specific part, and then I will tell system that, hey, this is the part. I would like to find out all the parts in the vicinity of that part in the range of say 5 millimeter or 5 centimeter, whatever I really want to find out. So that's where these are the two use cases that we are going to look at. So now I have opened this my BOM structure. You can see it here. So as I said, like my first use case is I really want to find out what are all those components are really owned by a specific user called as. Let me just put it here. I'll put the questions that uh, filter the BOM structure, okay, based on the data owned by, in this case, a corner. So that's the user I would like to filter the BOM structure. You can see that the BOM structure will be filtered, based on whatever the queries I have given. So if you look at this, so this is the sub-assembly is entirely owned by the corner, right? You can see that in this case, who is the user, corner design, right? That's the user here. You can see like all this data is owned by him. So I have just given the simple questions, filter the parts owned by corner in this case, and system has done that really quick to configure the structure based on the question that I have asked. Now the second use case is here. If I get into the open BOM structure, I can say like filter content. This is the second use case that we are going to look at here. Filter the content, within the range of 5 centimeter or of the selected atom. So for that, I'm selecting one atom here. You can see it here. This kind of screw pan head, and then filter content within the 5 centimeter of the selected BOM atom, right? So you will get this. It will show the components and it will filter the structure where all these components and the sub-assemblies are within the 5 centimeter range of that selected atom. So these are the kind of use cases. There are several other use cases also, but this for an example here, these are the two use cases that I was just trying to explain you, that you can configure your structure based on your questions and get the focused information from the bill of material. Now this is off use case. I mean, this was already there in the Teamcenter. Some of you may be already using it, but this is again leveraging the kind of machine learning here. So auto classify the data. So what happens basically, this is when you are having large set of data, it is very difficult to classify manually. So that is where this capability comes into play, and it adds a lot of value. You can significantly reduce the time and efforts when you are classifying the new object. So it has found that around 90% of 95% of the efforts can be eliminated when you employ this particular capability in the Teamcenter, right? So how does it work? Like say, for example, I have this square insert. I would like to classify it. So what the system does it start, understanding that part that I have selected, and it will try to see like in which class it can be a best fit. You can see there is a match which says 56%, another one is 10%. So obviously I will go with the higher percentage. Now what advantage here is, based on that earlier classified informations, I get most of my fields are populated, right? And Wherever I want to change, I can change. Wherever I want to add additional fields, I can go and add those additional fields, right? So this becomes really easy. I mean, you don't need to go and start from the scratch here. So you can see like all your informations are coming from the existing, based on the existing classified object, so that you can save your time and efforts in this. Now, I, I mean, there is an advanced mechanism where the system will classify the object and then you put it into the workflow, and a manager will go and check like whether everything is correct or not, and then accordingly update it, and then finally it will get classified. So those kind of use cases are there, but it saves a lot of your time. The last use case in this segment is, again, this is not a very recent. It is there, I think, not couple of. I mean, it's there in 6.2 or even before. So this is also on the similar line. I mean, it learns that um, how the expert user is using the systems, and based on that, it actually start offering those commands and the relevant data to the users. So this helps you to implement the best practices in the system, right? And it is pretty useful. I mean, if there is a user who doesn't know like how to use active workspace, so he can use this assistant and get to know about the commands that somebody from his team who is an expert user using it, and also the informations, right? It starts suggesting the commands as well as showing the relevant informations, and all this is based on the context and the history and the usage frequency of the actions performed by other previous users belonging to the same role and group, that it will be offering based on all that informations. It start offering those commands and the relevant information. So it is very, very useful in case of basically migrating from rich client to active space client, where it is difficult for training, kind of training the users, because they are coming from rich client background. So they find it difficult sometimes finding out those different commands and making use of that. So that is where like this functionality is really helpful. Okay, so excluding these last two, auto classify the data and this one, these two were already there, and actually these two are inbuilt functionalities in the Teamcenter, like assistant and the classification. They are using the Teamcenter database, and obviously there is algorithm to learn and all those things. But other functionalities which are is kind of based on the new architectures that I'm going to talk about. Now, so far we have seen like, what is AI, what is AI in Teamcenter, what all those typical use cases are there. It's a time for us to understand what is the architecture behind it, how can we deploy it, right? And what kind of configurations we need to really do to get this enabled in the system, and what it really takes, right? So let's look at this architecture here. So basically, this is a RAG LLM architecture. You can see RAG allows to train the model, based on the user query, and it always stays up to date. Whereas LLM generates the meaningful response based on the data in the database. So how this architecture works, maybe that I would like to explain you here. So it's basically user makes a query, user enters their query, it gets converted into the vectors. You can see here it generate the vectors representations, and by using the embedding model, as right, and based on that vector, the most relevant informations, vectorized user input, user query that goes to the vector database, and based on the what you can say the matching, it will retrieve that, and then it will apply the obviously the user query. You can see apply the Teamcenter access control, and then that input goes to the large language models, user query prompt and retrieve data, and it will generate the response and then that response will be presented to the user through the inference service. So this section is essentially AI stack. You see there are three key elements here: embedding model, we have vector database, we have large language model that we talked about. So Embedding are numerical vector representations, basically that helps, like words or images that capture their meanings and relationship in a lower, you can say like converting user inputs into the more of like machine, acceptable inputs, right? That's what it does. So this portion is like a user portion, and this portion is like kind of constantly updating the knowledge base. So you have ETL pipeline. So from Teamcenter, right? So once you have the data prepared for loading into the vector database, so you will use the embedding service. Data get extracted and chunked, and that gets stored into the a store vector into the vector database. So this is kind of a continuous process, so that your vector database is always up to date based on the data you are creating, based on the data you are modifying. It's kind of you can think of, if you are using Solar, it's kind of like continuously updating the index data in this case, right? So that's the overall architecture here. So now this is called as AI tech stack, because all these things are as part of AI technology. Okay, and now this stack is supported on cloud as well as on-prem. So you can use the models from AWS or from Azure or from on-prem, which is called as Llama. So now we'll talk about that. Now let's say if we want to implement Teams AI in Teamcenter, what we need to do. The first of all, it is required to upgrade Teamcenter to the latest version, and that can be 2506. And currently, I think 2512 is also available. So it is recommended that you get onto the latest version of the Teamcenter because 250 because the BOM Copilot is introduced in the 2506. So that is a very good value-added use case. So if you are looking for BOM Copilot, and so that is where like 2506 or the later versions are recommended to use. The second thing is we do configurations, for the AI platform suiting your business situation. You can go for Amazon, you can go for Azure, or you can go for on-prem. Then finally, obviously, there are certain features and microservices that you have to install in the Teamcenter. Okay, so before 2506, there was no BOM Copilot. So that's where you see like there is only a Teamcenter AI chat. By the way, this is deployment center. If you are still using Teamcenter Environment Manager, so-called TEM, you have to get onto the deployment center, and then you can see this feature. If you get into the 2506, then you will see additional component called as Teamcenter BOM Copilot. So these are the two things that you need to select and basically deploy in your instance. Now, these are the AI platform. As I said, like you can go for AWS Cloud Platform. There are embedding model, vector database, and LLM. All right, all three components are available. Same is the case for Azure, and the last one is on-prem. So now which one is better for me? There is no. Obviously, these are standard model. All three are standard model. Olama is also standard, and this all three are standard model. But the efficiency and the performance wise, we have seen like AWS is better than the Olama, right? So if you are having a liberty of using cloud service, you can, I would recommend go for AWS. But if you are looking for something on prem, then obviously you can go and use the Olama platform. Okay, so what is this like embedding model and vector database and large language model? So we already talked about it essentially. So embedding model is component, which converts your data, basically that we feed for learning into vectors. So what is the output you get from the embedding model is a vectors based on whatever the inputs we are giving, right? So your vector, you can consider it as an inputs that vector database can receive and store. So vector database store the vectors, and then large language model is essentially responsible for generating the human, conversational responses using the vector database. So these are the three key components in the AI stack. So which platform to use, it's all like up to you. But these three components are there in all these three platforms. Okay, so now let's get into the actual kind of how do we enable the AI chat and the BOM Copilot in the Teamcenter. As I said, get onto the 2506 or 2512, and then definitely you have to use the deployment center in the recent releases. So you choose these two features here, and then after providing the connection details, so basically you have three options available, like Amazon AWS, Microsoft Azure, and self-manage. So these are like SaaS services, software as a service, if you are getting on Amazon or Microsoft Azure. And if you want to say like I will be managing my own, then that's kind of self-manage where Olama come into picture. Right? Select your AI platform, and then obviously uh, this is a secure channel, secure communication, as I mentioned earlier also. So you get into you provide all your details. I mean, like access key and confirm all those secret key and so on. Is kind of a connection details here, and then you have a Teamcenter AI microservices where you will mention once you are having the connection. Obviously, you have to provide the additional details. After providing connection details, you have to provide like what is the name of your large language model, what kind of IAM role you are going to use. This is the case of Amazon, by the way. Vector database setting, open search, what is the endpoint URL, what is the IAM role for accessing that endpoint URL. So these are all the details that you will be providing here. And then obviously you have to generate the deployment script and deploy on the required server. Next step is creating the knowledge base. So there are certain steps here that we have to follow to create a knowledge base. So the first important step here is define the saved search. So you can define the saved search. Just like it's a normal process. Defining the saved search, you just find out the informations, your data sets based on your criterias. Here in this case, I have used a star, but obviously in your case there may be a classification of the data, or there may be some attributes based on that you would like to create the knowledge base, right? So it is not necessary that we have to use a star, even although I would say it is not recommended. Like we do not want to extract the knowledge from all our documents, right? So obviously you will have like a more refined query here. Just create a save query, and then obviously you have to make sure that that query is allow others to view and view, because this is not a query for yourself. This is a query will be used by the background programs, right? So that's why you have to make sure like you are selecting that. Then second of the things that we have to do is we have to configure the preferences, the TCA knowledge base name, where you have to give the saved search name, and indexable file extensions like .text and PDF. What are all those files? And these are all like standard preferences. It is not nothing new. Like if you are using Solar, these are all the preferences available. And then AWS asynchronous file, not AWS, AW. There is a mistake here. AW asynchronous file content underscore indexing enabled. Um, right, that you have to say based on if you are using it translation based, then you go and say to true. And if you're not using that translation, then you have to use it as a false. Then you have to go and do the indexings. So obviously, first the object should be indexable. So if your objects are not indexable, that like you have to get into the BMID and mark them as indexable, that you have to make sure of. And then there is a new, keywords called as embed, which is actually creating the inputs, right? That is required for AI chart. And if you are going for natural language, then you also have embed schema, right? These are the two things that is there when you run the FTS indexer. Then if you are using the BOM Copilot, so BOM Copilot is based on the smart discovery. I mean, it needs a smart discovery feature to be enabled in the system in this case. So you can use the different commands here, like indexing the Smart Discovery Index is there to create the index. Then there is a TCFTS indexer to keep it in a sync, right? You can see that so that it will be continuously synchronized. So these are the steps that you have to follow there. Now, I mean, we have seen like a couple the steps for actual deployment and the post deployment. Question generally I have seen like people ask like, what is the hardware requirement? This question does not have a very specific answer. No document has given a very detailed, I would say, the a very crisp and precise answer. But there are some there are some inputs given on how do you calculate your sizing for the hardware, right? So the first one is quantization use. So it is kind of range of values that can be assigned to the parameters weight. Like it can be an integer, it can be a float, right? So you can use based on that. Then second one is how the RAM is calculated. It's all like number of parameters uh, multiplied by bytes per parameters, and these bytes will come out from here, right? So that's the RAM size, and the GPU 1.3 star model size or RAM should be 2x of GPU. So you can go with this calculation, and the storage is calculated by model size plus data, right? Generally, 64-bit CPU for LLM is recommended. So you can see like on-prem implementation, you can go for this kind of hardware requirement like 64 GB RAM and CPU and GPU and so on, right? Now let me talk about the parameter because we have mentioned here like what the parameter is. So parameter is a unique attribute of your data. Now, for example, if you give a photo to the systems, right, there are some unique attributes. For example, number of eyes, the size of eyes, and the position of your eyes. So these are like the unique attributes. So that is what is represented by the parameter. Now, let's say in context of Teamcenter, obviously we are not going to give photos, right? Human photos. But here in this case, we'll be giving some documents, right? We'll be giving, informations in the PDFs and etc. etc. right? So it will identify, system will identify the unique attributes and train itself based on those attributes as parameter and then assign and adjust the weightage, which is of like more of a kind of how the responses will get formulated. It's all like parameters and along with the weightage, right? So it start matching those in the database based on those parameters and formulate the responses for your queries. Okay. So that is what I do have for today. Open for question. Thank you very much. If you have any further, if you need any more informations, you can connect with our business development manager, who's, I mean, on this slide, mention his number is also there, and his email is also there. So if you are looking for any kind of information or any support in implementing this, we would be happy to assist you in this journey here.
Yeah. Thank you, sir. It was a nice session. It was a great session, I think.